Hi everyone, welcome to my video on direct integrals by substitution. I know, exciting, isn't it? My name's Darren from, Maths Guru. Thank you very much for finding me. Hopefully this video is going to be useful. Now, you can see behind me that my learning objectives state we're going to understand how to use the theory from the previous lesson. What previous lesson? Well, they're all found on mathsguru.com, of course. Free to sign up. Videos are on there for the whole specialist maths course, or at least they're in the process of being done, and hopefully they're going to be useful. And if you can subscribe to my YouTube channel, that would be massive. Now, yes, it is very much going to build on the idea that we looked at substitution to help us integrate more complex problems. And again, I really do recommend you watching that video if you can. This has only got a few examples. It's a relatively short video, but it's just going to take that one step further so that we can actually evaluate definite integrals rather than sort of indefinite integrals. All right, so let's have a look at example number 1. We got the integral between 0 and 4 of 3x root x squared plus 9 dx. Now, word of warning, remember this 0 and this 4 come from the fact that whatever that function looks like, it's because we have x on our x-axis, and therefore we would be looking at finding our area between x is 0 and x is 4. All right, so that's really, really important for what's about to come up. I'm going to rub that out to give myself some real estate. Right, where do we go from this? Well, using the theory from the last video, I'm going to say, therefore, let u equals x squared plus 9. du by dx becomes equal to 2x, and so dx becomes equal to du on 2x. Now, the reason being is I can now write this as the integral, and I'm going to leave those terminals off for a moment, as 3x, the root of u times du by 2x. Now again, I get a little bit nervous. We were told in the United Kingdom that that mathematically makes no real sense at all. I certainly couldn't put it equal to, because we've got mixtures of x's and u's. So we're always taught to really do this line here. He says highlighting it almost as sub-working out before you go back and do what you need to do. Again, VCAR, I don't know how they work, but that x and that x were cancelled, and so therefore I can say I am now looking for the integral between, now I'll come back to that in a moment, of 3 u to the half times du on 2. All right, well, we know that we can move any constants outside, so that can now become equal to the integral of 3 on 2 of u to the half du. And life becomes much, much simpler, because I can now say, well, therefore, that's 3 on 2 square brackets, u to the 3 on 2 divided by 3 on 2, but we know, therefore, that can now be written as 2/3 to the power of to the terminals of. Now again, I keep pausing here with the terminals. Why? Well, there are two ways of doing this question. I can now convert that back into 3 on 2 square brackets 2/3. U we decided was x squared plus 9 to the power of 3 on 2, all on, sorry, not all on 3 because I've done that, between my terminals of 0 and 4. That is certainly one way I can do it. And the reason I know it's got to be between 0 and 4 is because that's now in terms of x. I cannot put 0 and 4 here because these were my